Welcome back to another video of class 12 mathematics chapter 1 relations and functions, and today's our topic is invertible functions. So let us first go through the definition. A function f such that x to y is defined to be invertible if there exists a function g such that y to x such that gof equal to ix and fog is equal to iy. The function g is called the inverse of f and is denoted by f inverse. In a simple way, first I'll explain the invertible function. Here we have function f. So from where to where it is? X to y is defined to be invertible. When it is invertible, if there is a function, how it is x to y? If there is a function where it is y to x, that is, now here x is your domain and y is your codomain. So when your function is reversed, so what happens? Your codomain will become domain. Just check. Here it is y and this y has become what? Here it was codomain and here it has become domain, and x has become codomain. So when it reverses, the function reverses, what happens? The domain becomes codomain and codomain becomes domain, such that gof equal to ix, identity function on set x, that is your gof is equal to x and fog is equal to identity relation on set y, that is fog is equal to y. The function g is called inverse of f and is denoted by f inverse, that is f inverse equal to g. If a function is invertible, then f must be 1 1. F must be 1 1. You remember in the previous lectures you have learned about different type of function, that is 1 1 function, onto function and bijective function. If a function is both like satisfying 1 1 as well as onto, then that function is also called bijective function. If f is 1 1 and onto, then f must be invertible. Okay. So first we'll go for an example. When you go through the example, you'll understand how to solve. Like when you're asked to find the inverse of f, like what you're supposed to, will see. Let f, it's an example 23 from your textbook. Let f such that n to y, natural number to set y, be function defined as f of x is equal to 4x plus 3, where y equal to y belongs to n, such that y equal to 4x plus 3 for some x belongs to n. Show that f is invertible, find the inverse. So here we have domain as natural number and codomain as set y. And what is a set y? Y is equal to 4x plus 3. That is f of x is equal to 4x plus 3. Okay. So find the inverse. So let's see how we are supposed to find the inverse. Solution. Always first you write the given. So I have written the given, and we know that we even write f of x as y. F of x as y. So if what here they are saying, x belongs to n. So x is some element in a set of natural number, and f of x is y. Okay. So y is equal to 4x plus 3. Your expression in terms of x equal to, next followed by, so g of y is equal to, and when we write x is equal to y minus 3 by 4, when we write x is equal to y minus 3 by 4, then we can even write, so that can be also written as g of y is equal to y minus 3 by 4. Why? Because f of x is equal to 4x plus 3 in terms of x, and when it is y, g of y is equal to y minus 3. Did you all understand why did I write g of y is equal to y minus 3 by 4? Because from n to y. Okay, so we know that to find inverse, we have to find gof as well as fog. So what your gof should be, it should be equal to x, and what your fog should be, it should be equal to y. That is ix is nothing, x and iy is y. This I have explained identity function in your previous class. Okay, so g of gof of x is equal to g of f of x equal to, what is f of x? We know that f of x is 4x plus 3, so that we have substituted. And what is g of something? So g of y, that is, if instead of y we have 4x plus 3, that can be substituted in this form. Okay, so what we get is 4x, so instead of y we'll be writing 4x plus 3 minus 3 by 4. So here 3 is deducted and we have 4x by 4. What is 4x by 4? Again 4 gets cancelled, and now what is remaining? X. So x is equal to in. Why it is in? If it is x, we write ix. Instead of x we have set of natural numbers, so it is in. Identity function on set of natural number. So next we will find fog. So fog of y is equal to fog of f of g of y equal to, what is g of y? Y is equal to y minus 3 by 4. And next step, you substitute in here. Okay, so we have 4, instead of x you will be writing y minus 3 by 4 plus 3. So here we have 4 gets cancelled, 4 by 4 is 1, so it gets cancelled. So what is remaining? Y minus 3 plus 3. So again minus 3 plus 3 0. So what is remaining? Y. So equal to iy. So I guess you have no doubt why it is iy, because the other set is iy. So hence f is invertible with f inverse is equal to g. So here it's proved. Okay, next I will go through a simple theorem. So here what we have if f such that x to y, g such that y to z, and h such that z to s are functions, then what you're supposed to prove? HO GOF equal to HOG OF. Let's see how it is. First we'll take our LHS. LHS is equal to HO GOF of x. Next step is what it's written? H of GOF is GOF of x, G of f of x. So H of GOF of x. So next, when we go deeper, so what happened? Again H of G of f of x. Got it? Next, for all x in x. Next we have RHS is equal to HOG OF of x. So next step, HOG f of x, H of G of f of x. So same thing, right? We have, so RHS and LHS are equal. We have RHS equal to LHS, so hence it is equal. So it is proved. Let's begin with the exercise 1.3. Till now we have completed 3 questions in the previous video, and from 4th question we have inverse function based question. So 4th question, if f of x equal to 4x plus 3 by 6x minus 4, x not equal to 2 by 3. Why x not equal to 2 by 3? Denominator 6x minus 4. So if denominator is, if the value of x is 2 by 3, what will happen? It will become 0. So you all know that, but still show that f that is of x is equal to x for all x not equal to 2 by 3. What is the inverse of f? Okay, what is inverse of f? We have to show what FOF of x equal to x, and what is inverse of f we have to find. So first let us write the given. So here we have written the given, done. So what we have to show? We have to prove that FOF of x equal to x. So FOF of x equal to f of x. What is f of x? 4x plus 3 by 6x minus 4. So that will be substituting here in place of x. So when we substitute, it looks like this. We know that when we cross multiply and all, denominator will get cancelled. So what will be remaining? So we multiply this 4x, 16x, then 12. 4 into 3, 12. Plus, when we cross multiply, this 6x come over here, and so we have 3 into 6x, 18x, minus 3 into 4, 12. Okay, the next same way here also. So when we cross multiply, okay, we know that after cross multiplying, denominator gets cancelled. Don't forget that. Don't think like where did that 6x minus 4 went. Okay, next multiply 6 into 4x, 24x, plus 18 minus then 4 into 6x. So minus 4 into 6x minus 24 minus 4 into minus 4 plus 16. So here we have done. Okay, so 12, 0. So 16x plus 18x, 34x. Here we have 24x minus 24x, 0. So 18 plus 16, we have 34 again here. 34 into 4 get cancelled, and we have x. So x equal to I of x. Okay, so we got this. I've just written for you to know. Okay, till here it is enough actually. Okay, so we have proved f of x is equal to x. So this is proved. So hence inverse of f is f itself. We got the f itself, we have got it. Okay, fifth question, state with reason whether following functions have inverse. 3 sub questions. First one, f such that 1 2 3 4 domain 2 10, this is our codomain with f 1 10 2 10 3 10 4 10. Okay, we'll go for that. Okay, here f is many one. Why many one? That is, if it is 1 2 3 and 4 goes to what? All goes to, all are getting paired with what? 10. See, got it? This is our domain, and where it is going, all are getting mapped with 10, that is getting paired with 10. So this is clear, I guess, everyone. So here f is many one. Here we have many 2 1. Okay, so f of 1 equal to 10, f of 2 equal to 10, f of 3 equal to 10. Nothing, indirectly we can write f of 1 equal to, f of 2 equal to, f of 3 equal to, f of 4 equal to 10. So f is not 1 1. Done. Hence function f does not have inverse. Okay, so we have done with this. Second sub question, g such that 5 6 7 8 2 1 2 3 4 with g equal to 5 4 6 3 7 4 8 2. See, but looking itself we can understand, if it is 5 it is 4. See, here it is again many one. Okay, so g of 5 equal to g of 7 equal to 4, that is g is many one. So again g is not 1 1, hence function g does not have inverse. Third sub question, h such that 2 3 4 7 9 2 7 9 11 13 with h is equal to 2 7, okay, 3 9 4 11. See, all are having unique image, unique pair, right? Nowhere there is any repetition. Okay, so all distinct elements of sets have distinct image. H is 1 1 as well as onto. Okay, hence function h has an inverse. So among the three we had only one function, that is function h as an inverse function. Here we have sixth question. Show that function f such that close interval -1 1 to r f given by f of x is equal to x by x plus 2 is 1 1. Find the inverse of the function f such that -1 1 to range f. Hint for y belongs to range f, y equal to f of x equal to x by x plus 2 for some x in -1 1, that is x equal to 2y by 1 minus y. Here our question says that we have to show that this function is 1 1. Okay, so first part we have to prove that f of x is, this function is at 1 1. Then second part we have to find inverse of f, that is inverse of f -1 to 1 to range f, right? So inverse means range f to -1 to 1. Okay, first let us show that our function f is 1 1. Solution. First we'll write the given. We know that usually when we have to show that a function is 1 1, we start with the mathematical representation of 1 1 function. So how is it? F of x1 equal to f of x2 by next x1 by, we know that what is a function, x by x1 x plus 2. So instead of x, here we'll be replacing with x1 by x1 plus 2. Here in case of f of x2, x2 by x2 plus 1. So when we solve it, here this x2 plus 2 will go to the left hand side and this x1 plus x2 will go to the right hand side. So we'll get x1 x2 plus 2x1 equal to x1 x2 plus 2x2. So here x1 x2 gets cancelled, and again next step will be having 2x1 equal to 2x2. So in that step we'll be striking out 2, and what will be left with? We'll be left with x1 equal to x2. Okay, so hence it is proved. So f is 1 1. We have, so I will move on to a second part. We have to prove it as inverse, right? So when we prove it as inverse in the previous case, we remember okay, what we have done, function f of x we have written x by 2, x by x plus 2, and then we have written what is f of x, y, we know that. So y is equal to x plus 2, x by x plus 2, followed by, why did we write this? Because we are supposed to write x equal to in terms of y. Now your expression here, it is in terms of x, so that should be in terms of y, that is x equal to. Our expression should be in the form of x equal to. So when we write, what will happen, x plus 2 will move on to this side, and what is the y into x, xy plus 2y equal to x. Then next step, 2y xy move this side, it will become negative, so x minus xy, 2y is equal to x, x is common, so 1 minus y, and later this 1 minus y moves this side, so we have x is equal to 2y by 1 minus y, that is g of y is equal to 2y by 1 minus y. So next, as we have to prove that f is inverse, so what will happen? In the previous case we had this as domain and this as codomain, it will get interchanged. So we have our new function g, so g such that new function g means f we have already used, that is our function, so inverse of f we are writing g. So we have range f as domain and close interval -1, 1 as, what do you call that, codomain. Okay, but you might be thinking, what is this range f? Range f is nothing. See here what it is, close interval -1 1. So what will happen here? What is x? X is between -1 and 1, as well as -1 and 1. It is between -1 and 1. So it can be any value between -1 and 1, including -1 and 1. Why? Because it is closed interval. Okay, now this is our set of real numbers. So getting paired, getting -1 having image in R, here 1 is having image in R, so all the elements between -1 and also will have unique image, distinct image, unique and distinct image. But reverse, but we know that set of real numbers other than -1, 1 and between those values we have here -2, which is not having image. We have here 2, which is not having image, right? Which is not having image. So pre-image should be there, right? But pre-image in this two, in remaining cases it won't be there. So in short, what we say, what we are using when we leave the remaining elements here in this set, so what is this actually? Range. Remember, you have learned range because when we started this chapter I have taught about the basic of domain, codomain, range and all. So this is range we are using. So range of f is what? Range of a function is what? From the set of real numbers. So we are using range f. 2 minus 1, 1. Gof of x is equal to, we know that we have to find gof. So gof of x is equal to g of f of x equal to g of x by x plus 2, and in order to explain you why we have taken this term. Okay, next, so where we are going to substitute this expression. So 2 instead of y will write x by x plus 2 by 1 minus, again we have 1 minus y, so x by x plus 2. So again in denominator case we cross multiply, so we get, so here we have 2x by x plus 2, here we have x plus 2 minus x by x plus 2. Here x plus 2 will get cancelled, so what will be remaining? 2x by x plus 2 minus x. So here x minus x gets cancelled, so what is remaining? 2x by 2 gets cancelled, we have x. Why did we write this I minus 1 1? Because this is our domain, right? Okay, so we have got x, we have found gof. Next we have to find fog of y, f of g of y. So what is our y? 2y by 1 minus y. So what we had as a f of x, y is equal to x by x plus 2. It's there in the previous slide, but still okay. So instead of x we'll substitute 2y by 1 minus y, and x here again 2y by 1 minus y plus 2. So after here denominator cross multiplying and all, 1 minus x, 1 minus y, 1 minus will get cancelled, so we will have 2y by 2y plus 2 minus 2y. So here 2y minus 2y will get cancelled, so remaining 2y by 2, so again 2 gets cancelled, so y. Okay, so this is also okay. So for gof and fog we have solved. So hence in gof we got x and in fog we got y. So as per definition we have proved that f inverse is equal to g, that is the function f is an inverse function. 7th question, consider function f such that R2 are given by f of x is equal to 4x plus 3. Show that f is invertible and inverse of f. Invertible means you have to prove, you have to show 1 1 as well as onto, and inverse you have to find gof and fog. Okay, so given we have written, so first we'll find go for 1 1. So we know that mathematical representation as written here. Let x1 comma x2 belongs to R. F of x1 equal to f of x2, and we know that f of x is f 4x plus 3, and here we write 4x1 plus 3 equal to 4x2 plus 3. Next 3, okay, then 4x1 equal to 4x2, 4 gets cancelled, we have x1 equal to x2, therefore f is 1 1. So it is satisfying, so f is 1 1 function. Next, for on to, again we start with the mathematical representation, how we do, like for on to how did we do in the previous classes and all. So for y belongs to R, let y equal to 4x plus 3. So we write in terms of like x equal to y minus 3 by 4. Obviously when we substitute values it will belong to real numbers. Next, f of x is equal to, when you substitute it you get y. Okay, y also belongs to real number, therefore f is onto, hence f is onto and 1 1, therefore f inverse exists, that is f is invertible, that we have proved. Next, find inverse of f. So g is such that, so we take a new function, okay, inverse, f inverse is equal to g. From definition we have learned we can take g. Okay, so here we are taking the inverse of f as g, R to R. So here domain, codomain, when we interchange, when in the case of inverse it doesn't make any difference. Why? Because both are set of real numbers. We know that x equal to y minus 3 by 4. Okay, this already we have written, so we can repeat it. First, why we are taking it? Because we have to solve for GOF and FOF. For that purpose we need it. So g of y equal to y minus 3 by 4. This also I have explained previously why we are writing g of y. So GOF of x is equal to, we know that we have to find the inverse, we have to find GOF as well as FOG. So GOF of x is equal to g of f of x. What is f of x? 4x plus 3. So g of 4x plus 3. And after substituting we have, instead of x we write 4x plus 3. So 3 plus 3 minus 3 0. So remaining 4x by 4, and 4 gets cancelled, then we have remaining x. So we got x. So GOF is equal to x. So GOF is satisfied according to definition. Next, FOG of y equal to f of g of y. So what is our g of y? Y minus 3 by 4. So that we have written. So in f of x we'll be substituting it. So 4 instead of x we'll be writing y minus 3 by 4. Here 4 gets cancelled. We have y minus 3 plus 3. So minus 3 plus 3 again gone. So remaining y, again FOG is also being satisfied as y. So hence f is an inverse function. So here till 7th question we have done. Thank you.